on in this video, we will learn how to use a breadboard and understand how they work. So this breadboard is a 140 pin breadboard. However, there are many different sizes. As you can see here, this breadboard is the really large breadboard. Going back to this small breadboard, it should be enough to demo and understand how to use it. So this is the front side. We can see that there is a plus and a minus, minus plus, and then the center piece, which has numbers 1 to 30 and A to J. Now, this is what the back of the breadboard looks like. You can see the metal plating on these two and on the side. Now, for demo purposes, I'm gonna break these apart. And normally, you don't want these exposed. So, let's talk about first these two pieces. As you can see, there is the minus and the plus, and the line has the color going all along the side, and the minus has all along the side. If you follow the rail, the plus rail, the metal piece goes all the way down as well. Same with the minus. So these two aren't connected at all. If we do a conductivity test, which is a test that determines whether or not there's a short or if they're connected, the metal pieces are connected, we can use the multimeter and change it to that mode. And if we hear a sound, then they're connected. Let's touch the minus part. If I were to touch anywhere along the right or the left rail, you can hear the sound of the beep, meaning that anywhere on this rail, it's connected. If I were to put it inside the pins, right, along the whole rail, it should be connected. Similarly, with the plus sign, and then inside the pin as well, right? So if I were to get the minus and the plus connected, like this, there shouldn't be any sound because these two are individual and independent, right? These two power rails are disconnected. Now, looking at one of them, the positive side is usually your VCC. Or in the schematic, usually it's the positive end. The negative is usually your ground. So to prevent from any confusion, let's stick to that convention where the positive is VCC and the negative is ground. These two rails right here are not connected. In fact, they are individual separate components, why I can take it off, right? So to connect these two, you want to use them to power different places on the board. Let's connect them using a jumper wire, and all you gotta do is just poke the cable through one of the pins, and that would mean, again, that everything on this whole rail on the positive side should be connected to this whole positive rail. Similarly, you want to wire the two grounds together, as so. It is very important to ground all the grounds. Sometimes you might have two different voltage types, like 5 volts on this end or a 3.3 volts on this end. But normally, and very importantly, ground must be grounded. Going into the main section of the board, we have a different type of sequence. Now we have everything being horizontal rather than having it vertical. So this center line disconnects in the middle, meaning that if I break this in half, hypothetically, this shouldn't be connected to this at all, right? So conductivity test, these two are not connected. However, these two are, and these two are, right? Just follow the line. Flipping it over, I would expect that this rail is connected to each other. However, these rails are not. Looking back, you would see that these all have a gap in the middle. If I look closely, it's metal, gap, metal, gap, metal, gap. So that would insist that these two, rail 1 and maybe rail 4, are not connected, nor is rail 2, 3, 5, 28, etc. And the purpose of this, if I were to connect these back together, is that this enables multiple connections to be put through in the middle. Let's say if I have an IC chip like this, you want every individual pin to be at a specific and different spot. So normally, how they work is you just put it in the center. By putting it in the center, each pin will have its own individual rail. Even if it's the same number, it's a different letter, right?